Good morning, Grid Connections listeners. And for those of you who may be listening for the first time, the Grid Connections podcast is the show where we unravel the complexities of electric transportation, renewable energy, and our electrical power grid that ties all of them together. I'm your host, Chase, and today we're thrilled to have Rustam Kocher, a visionary retired trucking executive known for his pivotal role at Daimler, where he spearheaded the electric Cascadia trucking program. Our conversation was amazing. I felt like I knew quite a bit actually about electric trucking, but I really did learn so much with our discussion. In fact, our conversation went for so long and we covered so much that I had to break up our conversation into two parts. So dive deep with us as we explore the first part of our conversation with Rustam, discussing the electrifying challenges and achievements in electric trucking. From the adoption of the game-changing Megawatt Charging Standard, or MCS for short, to the future of autonomy in the industry. In this episode, Rustam shares his invaluable insights on the roadblocks and milestones in electrifying the trucking sector, enhancing EV charging infrastructure, and the exciting prospects of electric trucking domestically and abroad. It's a conversation packed with expertise and foresight you won't want to miss. But before we start, a quick reminder. If you find today's episode enlightening, do us a favor and share it with someone you know who would appreciate these insights just as much as you do. Word of mouth helps us grow and bring more valuable discussion like these to you. Also, don't miss out on our weekly dispatches of knowledge. Sign up for our newsletter to stay ahead of the curve with the latest trends, discussions, and exclusive content from the Grid Connections podcast. Plus, do you have a topic in mind or guests you've been dying to hear from on our podcast? Reach out to us. We're always on the lookout for compelling stories and voices to feature on our show. Email guests@connectingthegrid.com. Once again, that's guests@connectingthegrid.com, or reach out to us on our social channels. And for those intrigued by Rustam's journey and eager to learn more about his current endeavors, be sure to check out the show notes after the episode. There's a treasure trove of information waiting for you. And with that, enjoy.
Good morning, good afternoon, good evening, wherever you're at, listeners. My name is Rustam Kocher. I actually do the heavy U on Rustam, but that either way is correct. I fell into electrification actually before I ever joined Daimler Trucks. I was at Nike at the time in supply chain and sourcing, and I had an old Nissan Altima that I wanted to get rid of because I got tired of paying the gasoline bill. And this was around 2010, and there wasn't any electric cars out there. So I went looking for them, and I could buy a Zebra Zap, which is a three-wheeled Chinese lead-acid battery piece of crap that I think went 40 miles an hour and had 40 miles of range and had zero safety features. And I was like, that doesn't sound like a car that I want to put my family in or even be in. But then I started to do some research, and the Nissan Leaf was coming out, and then I got into who killed the electric car and looked at the Chevy Volt, and I started to do some research. I was born and raised in Portland, Oregon. I wanted to stay in the Portland area. There was one automaker in the Portland area, and that was Freightliner. And they make really big Class 8 trucks and Class 6, 7 trucks. And I decided to go in with the objective of becoming a bit of an inside agitator, kind of the guy that throws the Molotov cocktail over the wall and sees what happens. And so I was able to finagle myself into a sourcing role there because of my experience at Nike. And I was purchasing essentially the elements of an electric vehicle, spinning electric motors, so starters and alternators, batteries, lead acid 12-volt batteries, and all the electrical components that kind of go into those things. And by doing so, I got a great lesson in who the suppliers were, what the technology was, how everyone was preparing for electrification. What I found out was that I knew more about vehicle electrification than most of the suppliers did, certainly more than Daimler was prepared to do. And so quickly I kind of became the expert in the space within Freightliner. I started literally printing out articles about the Tesla Semi and the Nikola electric Semi and things like that, leaving them on executives' desks. Quickly graduated to email and some newsletters that went around internally. We grew from 3 to 3,000 on the email newsletter distribution list within about 3 years. And so, yeah, it just kind of grew to position myself to be ready for when Daimler was ever going to take that electrification leap. Funny story was when I was first hired, the new employees have a chance to kind of raise their hand in one of these all-employee meetings and ask a question of one of these high-level executives. And so I raised my hand and I said, so when do we plan to divest ourselves from diesel engines and move to the next generation of whatever is going to propel our trucks? And, what's that look like? And he literally laughed and said, oh, diesel will be, will be the fuel and engine for the next foreseeable 30 years. So there's no need to change. To which I said, I don't think so. And I kept doing what I was doing. And then Freightliner decided to start, actually Roger, who was the CEO at the time, decided to start an internal, what they call a swarm within Daimler, which is the German version of a school of fish, which is kind of an internal startup. And we got to name ourselves and the whole bit. And so you have the Mercedes AMG, which is the performance side of things. And we called ourselves EMG, the e-mobility or electric mobility group. And we were tasked within 2 years to come up with, is this a feasible thing to do as far as electrification of our trucks? And within 3 months, we had built an EM2, so class 6-7, and a class 8 e-Cascadia. We had built them from the ground up using existing chassis and cabs, and proved that, yes, the technology was there. We could do it. We could build them. And then we had to prove the market case, which took us slightly longer. But about 5 to 6 months, we were essentially done and said, yes, it's technically feasible. There's a business case for it. And not only that, but regulation is going to push us in this direction. So we need to do it. And we quickly grew from 11, which was the initial group, to I think there's over 300 now that call themselves EMG within that. So it was a pretty cool thing to be involved in and to help start up. And I'm excited about the fact that we have series production now, Freightliner e-Cascadias and EM2s being sold to customers. And they're even on Gen 2 for the e-Cascadia, which is really, really cool.
Yeah, no, thank you for sharing all of that, and that actually has brought up so many more questions with that. But I know we've got some stuff we want to go over. But I guess real quickly, I would be curious in that, because one of the things I wanted to ask you about was if you could, how much you could share of it. But it's around the organizational change required and kind of pushing that, because that is such a big change.
Yeah.
And it's funny you share that anecdote about them being like, no, we'll be diesel forever.
Yeah.
And coincidentally, one of my best friends actually took a job a couple of years ago, and he now lives in the Midwest selling Volvo semis.
Okay.
And so he's got his own. He's I would say optimistic, but very skeptical. And then of course his buyers are very skeptical of electric trucks. But I'm just kind of curious of what you saw, and if there was any. Maybe tactics is the wrong word, but any tactics or other ways to kind of win people over, or to kind of highlight and show to them that this can actually work and that there is a future for this.
Well, one of the first things we did was tried to get as many executives into electric cars as we possibly could. Now, the problem is Mercedes didn't have any to speak of. They had a B class that was built by Tesla that was honestly not a great performing vehicle. And so we got them into Tesla's Model S, Model X that was available at the time. And just we'd rent them on Turo, and we'd say, here's the key card. Go drive this car for a week, a month, or whatever it takes, and then come back to us with questions and concerns. And obviously anybody who's driven electric, sort of decent recent electric, there's all the torque, there's the smoothness, there's the quietness, there's the practicality, and then there's the challenge with charging. And so those are the things that came up. Wow, this is really smooth. It's really torquey. It's fast. It's quiet, but it's a bitch to charge. And so how do we solve that? And so we said, well, for trucks, we need to be able to show that charging infrastructure can work for trucks, but it probably needs to be purpose built. And so the next step was we built a charging station. And as far as we know, it was the first public truck and bus charging station in North America, if not in the Western world. And it was actually a partnership with Portland General Electric, which was the local public utility which serves the Portland area. And it's a 50-50 split. In fact, we got PG into a little bit of trouble because they agreed to that without getting express approval from their body that manages them or approves what they can spend their money on. And about 3/4 of the way through that project, I actually moved over to PGE.
I actually have a funny story I need to tell you about that. Just on it, we'll talk about that offline. But yeah,
Okay.
I was,
Right.
and what you're referring to is, I believe it's called now Electric Island, kind of
Yes, that
in
is Electric
North
Island. Yes.
Portland, there by the
Yep.
Daimler headquarters.
Yep. That's the one. And so I actually jumped over to Portland General Electric about 3/4 of the way through that project. And so I managed it. So I started it, helped design it, helped build it and get the partnership going. And then I jumped over the fence and helped to finish it on the PGE side. So that was pretty exciting. So we kind of had to show the world what charging for trucks should look like. And as part of that, charging speeds is an issue, or it's a question. So a Tesla semi or any large semi that's going to travel for a full 8-hour or 10-hour day probably needs to carry between 700 kilowatt hours to a megawatt. And if you're going to charge that at 1C, that means you need to be able to put in 1 megawatt of charging power.
And I guess that's a totally great point. And I didn't mean to cut you off, but just in
No, it's
case
all right.
anyone's listening, what 1C refers to is essentially the charge rate in comparison to the battery.
Correct.
So as you kind of said there, Rustam, if you have just to keep it simple, if you have 1 megawatt hour size battery, you almost need to have 1 megawatt of power, and then you're at 1C. If you go to 2 megawatts and it's a 1 megawatt hour, then you're at 2C.
Correct.
But I'm sorry, continue.
Roughly the time that it takes to charge in an hour, give or take.
Correct.
So if you have a 1 megawatt battery and it was at 0 and you charged it for an hour, it would get to full 1C, 1 megawatt. None of those things are exact because it's going to charge faster when it's low and it's, yeah. Anyway, it's a rough approximation, 1C, 1 megawatt, 1 megawatt charging speed. So that came up fairly early on in 2018 when we started to get into, what needed to be done for charging speeds and public charging for the trucks. And Tesla actually rang us up and said, hey, we want to work on this project with you. We can't charge at the speeds we want to with any of the existing connectors in the marketplace. And so we need to come up with a new charging standard for our semi, because they had announced the semi, as well as any other commercial vehicle. And the idiot that I raised my hand and said, sure, I'll lead the global effort to try and standardize this. Having never participated in a global standardization project before. I never should have done it. I'm not an engineer. I don't have that background nor experience. But what we have today now, after almost 4 years, is an MCS connector. So if you look for the Megawatt Charging Standard, MCS online, you'll see a triangular shaped connector that has now been essentially almost completed from a standardization standpoint, and will, I think, be rolled out later this year in 2024 and put into use on trucks in public charging stations. I believe that some of the first will be in Germany on a partnership site with Traton and a couple other manufacturers between Berlin and Düsseldorf, along kind of the east-west axis there in Germany. So that's pretty exciting that those will go into use. You've seen another connector that Tesla's using at their Pepsi site. They were required to deliver those trucks in a certain amount of time based on the state funding that was being applied to that Pepsi site. And in order to meet that timeline, they had to go to market with the stage of the development of the MCS connector that we were on at the time. And that was that square connector. And so we've had a couple iterations since then with that global project, and we've reached that triangular plug. The hope is that Tesla will come to the market with the series production of semi with that same triangular shaped plug on the truck, so that any fleet that has a mixture of Volvos and Mercedes and whoever else is out there and Tesla will simply be able to use the same charge plug, and we won't have a mixture of DC charging plugs like we do with passenger cars today. And that was the intent. The intent was to make this plug so that it would be a worldwide standard. So you could have a truck in Germany that could run in Portugal, that could run in Russia, that could run in the US, that could run in Venezuela, and everyone could use the same plug.
Yeah, and from what I've seen, yeah, there's been a few different iterations of it, but the last one I saw, and I believe this is the one you're talking about, is essentially looks kind of like a rounded triangle from the
Yes,
outside, and then there's
yes,
essentially two main DC pins, and
correct,
then I think two or three like communication pins as well.
correct. You have the
Um, and
proximity and
so
comms, and you have an in and out on the comms, and yeah,
Yeah, and so it's actually, I mean, it's pretty big, but it's still like smaller than like the traditional Chatamo plug.
yep,
Um, so it's not like absurdly big. And when you're talking about the power it's dealing with, you're like, yeah, this seems totally reasonable.
yeah,
And anyone that's ever been by like a commercial fueling station or ever just even dealt with using a gas pump there, it's actually would be you just plug it in and it goes. So it's really not that from a user experience, it's probably just as good, if not better, really, because you can just kind of leave it and walk away, and it's still a pretty light device. I'm curious, as you're going through the evolution of this, um, you talk about the one that Tesla goes to market with, and I've seen
yep,
that one where it's maybe people that are listening have seen it on TV where it's almost like square from the outside, kind of, and there's
correct.
two like main vertical pins.
Two blades, yep.
Yeah, is there as you're going through this, what did you find was the biggest thing dictating this evolution through these different styles? Was it the communication protocols? Was it the need for kind of over and beyond safety for delivering this power? Or was it maybe a mixture of all the above?
Communication protocols was an active conversation throughout from the start to the finish, honestly, and it didn't really get finalized until late last year through a voting process in the standardization body in Europe. Um, Primarily, we made the decisions we made as a group. We really started with the use case, and we started with the customers and the OEMs and the utilities, and we said, okay, let's help define what this needs to do, how it's going to be used. Do we want people to have to use safety equipment in order to utilize it? We said no, so there should be no safety equipment. Who's going to use it? Well, essentially anyone is going to be driving a commercial vehicle, so it has to fit, a use case of maybe a small young female or an older elderly driver that has to be able to climb down and plug it in. So it can't be too heavy, it can't be too unwieldy. It has to be usable by not only the peak of the human condition but the edges as well. So how do we make this so that the insertion forces and the removal forces aren't obscene and people can actually use it. But then again, at the same time, that it's safe, that it can conduct these 1 megawatt levels of
Right.
power or more in a way that's not going to put anybody at risk. So we said, safety, usability, no safety equipment, things like that. And so that's how we kind of came up with defining what it should be able to do, and then we defined from a technical standpoint then what it should look like. So there's what's called creepage and clearance distances, so that you don't have any voltage that decides to leak out when it's under power, because voltage can jump if given the chance, if it's on a dirty surface, things like that. So I learned a lot. We actually had one whole lesson about the physics of energy transfer and how close things can actually get under, what amount of pressure is kind of useful and what is too much, or essentially no longer useful, doesn't give you any additional contact force and reduce the amount of heating between the two materials, things like that. So again, I'm not an engineer, but I learned a lot during this
I'm sure.
process.
Yeah.
And we learned that it's easier to tighten um, the connection on a round face than it is on two square faces. You can
Hmm.
kind of push with two square faces, but it's easier to cinch down a round face and get the kind of connection, durability over time, so that you can have the insertion and removal forces that you want, but still get a nice clamp force, things like that. So that's how we came up with what we did. And we chose the V shape because as a user, it's easier to kind of slot that into the V, then tip it up and
Interesting.
push it in, things
Yeah.
like that. And then we defined where it should be on the truck, which makes the cable length a little shorter. So that was a bit of a fight, but in the end, we said left-hand side of the vehicle in all markets. So whether it's in the UK or in
Hmm.
Germany, it's on the left side of the vehicle, roughly hip height on the average human, so the insertion and removal forces aren't too bad. And then behind the most rearward forward axle, and in front of the most forward rear axle. So, which is a fancy way of saying between the axles, because sometimes you have a double steer in the front and you have two axles in the back. So between the axles, left-hand side of the truck, roughly hip height. So it gives you kind of a trapezoid shape with the connector in. And that way your cable doesn't have to be too long. So you don't have a really long cable that's liquid cooled being draped around and have to run, you're talking a Class 8 truck, you potentially could have, 10 meters of cable if the connection point was on the back or the front or the nose.
Right.
It's a giant vehicle. You see the long cables with passenger cars today. So that's how we defined it, and that's what we came up with.
Yeah, that is actually a really interesting point and pretty smart to make sure that doesn't matter what market, it's kind of in the same place and especially on the same side. Because I guess in a different realm, the Tesla supercharger is opening here in North America, and I guess they have actually been open in Europe for a little while. The whole issue around what side it's on kind of causes where the car and blocks another charger. So that's very interesting and makes a lot of sense. Now,
and I have lived that. I have a Volkswagen ID3 here, and I end up blocking 2 spots when I charge using a Tesla charger. So I've come to start to use the last one on the row, and I park sideways to it, so I only take up 1 spot.
Oh, interesting. Okay.
But you can't do that with the semi. With the semi, right. Pull through with a trailer. You kind of have.
You can try that, but I think you're gonna definitely get into some not so friendly conversations.
Exactly.
With that. So Electric Island, when that went in,
yes,
I mean it's still in, and I remember hearing they're going to do like a second round of upgrades to it. I don't know if that's happened. I don't know if you do, but when it originally launched, it was essentially just CCS1 connectors, high voltage ones. Yes. But yeah, essentially that's what the Daimler trucks would use, is they would plug that in. The idea was, and I think they eventually did open it to the public to use as well.
It was open to the public from day one. Actually, the day we opened it was open to the public. In fact, it was free for about the first 6 months because we couldn't get the payment software to overlay correctly on the multitude of chargers that we had. And so if you rolled up and you were a ride share, you got free electricity for about 6 months. So there were some pretty happy people there for a while.
I am sure.
It was all CCS1 connectors. We had a couple CHAdeMO. We had all the way from 50 kW for like an overnight style charge all the way up to, I think they've got a 450 there now.
Oh, cool.
And we've got a stretch between 400 volt and 800 volt. We've got the capability to put in the automated connector system like a robot. And then obviously we planned for MCS. So the MCS capability the ability to install an MCS, multiple MCS, as well as a BESS and solar there are all there. So we made the site as flexible as possible. In fact, if you look at the overheads of Electric Island, you'll see kind of a concrete strip that runs through, and under all of the chargers, that's actually a trench with a cement top, and you can just pop that trench, drop new cables in, close it back up, and you can actually switch out a DC fast charger probably in about 2 hours.
Oh, wow.
Most sites it would take you 2 or 3 days. So it's got a tremendous flexibility.
So it seems like there could be, like in the quickest version of that, could you, or maybe it's dependent on the actual charger unit, might not be able to speak the language, but could you literally just swap the cord out and then it would have MCS, or does the charger also need to be replaced to, I guess what I'm curious about is like the communication protocol. Is it CCS based? Is it its own thing? Does that make sense? Like how you can swap out
there, I believe you'd have to drop some new cable. I don't know 100% the answer on that. I think what they finally decided in the standardization body was to go with Ethernet. And I believe that cable is different than going via PLC or CAN, which are the other 2 communication protocols out there that we're considering. So I believe you would have to drop in the cable.
Gotcha. And does it... is there a kind of version of plug and charge or something supported, or would it also kind of require the payment side of stuff where each time it plugs in, I'm just kind of curious about that.
No, the intent is to use 15118-20, which does have plug and charge integrated. So yeah.
Cool. Very cool.
So essentially you would carry the ID within your vehicle of who you are and who's paying for your charging. You simply plug it in and walk away. That's the intent.
Very cool. With that, I think unless there's anything else you can think of, it seems like we covered a lot on the MCS, but that's really fascinating. And I really appreciate that because we really don't get to talk about that too much. It's usually around CCS and Tesla standards.
Well, the
So
idea behind MCS was essentially to try and put a bullet into hydrogen.
hmm,
I will admit
interesting.
that I feel that hydrogen is a little bit of a it's a push by the oil and gas industry to stay relevant. Kind of what they do is drill and refine and pipe and ship liquid and gaseous fuels, and that's their business model. And so that's what they would like to do with hydrogen. But the only substantial difference between performance difference between a hydrogen and a BEV truck is that you can fuel a hydrogen fuel cell truck faster, and you get slightly more range. Well, we know batteries continue to improve from a gravimetric what's the other term? Uh, power density,
Hmm.
capacity. And so they're able to hold more power and accept more power over time as they improve. And so we know that we'll have the capacity on a BEV truck as much or more as a hydrogen truck. And with MCS, the charge time is roughly the same. So it essentially puts the hydrogen fuel cell truck to bed because cost per mile, BEV beats it every day.
Yeah, and that's really interesting because that's something I've talked with people a lot. And from like a energy and scientific standpoint, I kind of get the argument for hydrogen. But when you look at, once again, like it to me reminds me of where consumer electric vehicles are maybe like 5 to 10 years ago in some ways, because like
Yeah.
obviously back then there was a much larger argument for hydrogen for consumer vehicles.
Yep.
And now that's kind of fallen away. We're
Yep.
even seeing the few that were still open in California are even closing down.
It's an
And
efficiency argument. If you have the electricity to make the hydrogen, then you've created a hydrogen that then you have to compress and ship,
right.
and then you have to put it into a storage tank at a dispensation facility. You have to dispense it, and then you have to turn it through a fuel cell to electricity into a battery that you then drive. You're already 5 steps behind an electric motor and a battery because electric motor battery, you simply put the electricity into it and it runs the battery. So
I,
if you simply take that electricity that you're going to use to make the hydrogen and use it for the truck, you're already ahead of it.
Yeah, and I mean, I don't mean to be a fear monger, but I think the concept of using hydrogen and the Hindenburg analogy to it, but then the fact that it's under pressure, there's just all these things that really compound it to like make it not as energy dense because you have to have under pressure, you have to have a much larger thing to keep it. But
Yep.
even then, I think the thing that I'm even consistently surprised by that people don't fully realize, because I think the biggest area where we're seeing this when you talk about the traditional fossil fuel industry is around natural gas and making the
Yep.
conversion from natural gas to be hydrogen moving. And the problem is hydrogen is the smallest atom. And
Yep.
it's not like slightly harder to contain. It's
It's much
much harder
harder. And
to
then you get
contain.
something
And
called hydrogen embrittlement. So if you use those
yeah,
same pipelines that you use for natural gas and you try to use them from hydrogen, they will just start to crack. And again, the hydrogen's the smallest atom, so out it goes, and it will come in contact with the source of flame, and you've got a big boom. So
yeah, I mean, it's a very different form of transportation. But if anyone that's curious, the best thing they can do is go research the space shuttle, because it was a mostly hydrogen powered, and it is one of those things, kind of in theory, and when you first think about it, makes a lot of sense.
yeah,
But then in practice and execution, it really starts showing its shortcomings and how much is required to make it work.
correct.
And unfortunately, it can go wrong very quickly. So
Yeah.
we've said enough, I think, about hydrogen on that. But no, I really appreciate that. And one thing you mentioned that I hadn't really thought about before, and I'd kind of like to hear more about, is you said it takes roughly the same amount of time to fuel hydrogen as it is with an electric truck. And I know one of the things I've talked to my friend who does sell Class 8 semis, and these are people who are doing big trips in these semis. But I
Yep.
mean, even with new regulations, and I will say, I'm always there's a fine line with regulations, but as a person who drives a lot on highways, the
Yep.
idea of like making drivers have to take more breaks and be safe about it, I'm okay with that one.
Yeah. Same.
Because everyone's human and there's just a point that you can only push someone so far. And what is interesting is I believe is it every 8 hours or 10 hours now,
You're required to
that,
take a break. I believe
yeah,
in Europe it's actually shorter. I believe it's 4 or
right.
5 hours in Europe. In the U.S., I believe it's 10.
Yeah, and I think
But
it
yeah,
used to be 12, and or
yeah,
if not more.
yeah,
And they essentially brought it down to 10, which is still a long day behind the
yeah,
wheel. And once again, not to say they can't do it, but I think that's a pretty fair compromise, honestly, at 10 hours.
yeah,
And so what is interesting is like when you look at how big these trucks are and how fast they can go, you get into certain states here in the US where it's like you could be going in the 70s, and that's obviously kind of hitting your efficiency and stuff. But
yep,
it's it's kind of now at the right point that as long as you have the charging stations at the right location, when
yep,
these drivers have to take breaks anyway, the charging, even with the current technology, aligns pretty well with how long they and how frequently they have to brake to
exactly,
charge. And I'm kind
exactly.
of curious
That
when
was
you
on purpose.
mentioned, is that kind of what you were alluding to? And is that
Yeah.
similar with what you've seen with hydrogen trucking?
Well, the MCS again. So when we started, before we got into any sort of design parameters or what it should look like, we said, what does it need to do? And one of the things that we decided that it
Yeah.
needed to do was hit that driver brake and get it to 80% roughly so that they could get back on the road again and continue until their next break. And so that was the intent, was to hit that 20 to 25-minute window to get them from 10% to 80%. So how do we do that? Well, we need to dispense at 1C, 1.2C. Okay, what connector needs to be able to do 1 megawatt, 1.3 megawatts? Okay. So, then what does it need to look like? How much power does it need to dispense? Those sorts of things. So that's how we got to there. And so we started with the uh, kind of that short break, that 20-minute break. What does that look like? And that's what we tried to hit. So, and that's why we came up with the parameters we did from power. We also wanted to stay under 1200 volts because if you go above 1200 volts, it gets into some safety regulations in some markets where you do have to wear safety equipment or have to have special training in order to operate the equipment. And so if we stayed under 1200 volts,
Interesting.
we could avoid those things. So, like I said, it was a lot of learning. But at 800 amps,
Yeah.
1000 volts, it starts to, that's a lot of power, but you can start to hit those 20, 25-minute
Right.
top ups. And you see the Tesla Semi doing it already with Pepsi. They're only operating at 700 kW, where they can do a 30-minute driver break at lunch, get that truck back up and running. And they did that, 1,200-mile day when they're doing the drive on less. So, we know it's possible for sure.
It's interesting you mentioned the Tesla Semi, and you said 700 kilowatts. Do you know if that's limited by the truck, or is that limited by the charging infrastructure they're using currently?
I don't know the answer to that question. I just know that that's the number that they've shared
Gotcha.
with everyone. I have had some
Interesting.
conversations with engineers on both truck and charging side, but those are private.
Yeah. No, I'm sure. I realize you hadn't worked there. I just wondering if there's more of just a general question. But I mean, even if you can make it even work at 700 kilowatts and you have it already kind of almost future proof to get to that megawatt thing,
We
that makes
wanted
it a
to we
pretty. I
wanted to
mean,
make some
that's
room on top, so we knew that we could
yeah.
hit certain things now, but we also wanted room for growth because both of the CCS1 and CCS2 were essentially topped out. There was no more room for growth when they were
Right.
starting. So we said, okay, let's make this connector able to grow, give it some headroom so that if somebody did want to push it, they could. And the funny thing is we only set out to do this for trucks and buses. And then here comes marine, and here comes aviation, and then here comes mining, and here comes
Interesting.
all these like event space. And like, can we use this? And we're like, sure, whatever. So now it's like if it rolls, floats, or flies, and you need a lot of power, have that. So MCS is the solution to a lot of interesting problems.
That's pretty cool. And that is actually something else I wanted to ask you about because they're all, whether you're bearish or bullish on this, there's all these new VTOL companies coming out.
Yep.
I was watching an interview recently. I think there's definitely a market for it. I don't know if it's a large disruptive market unless you're a helicopter business, but there's definitely certain areas, maybe in Europe and definitely like the Bay Area in
Yeah.
the US where it's like, yeah, I could see that there's definitely a use case for that. And one of the things they were talking about is like, oh, we don't know what charging equipment we're going to use yet. And so it's really interesting you mentioned that because like that almost seems like because their batteries aren't nearly that big. I figure it'd be like
No.
something more like even just using a Tesla, the new North American charging standard actually would be like perfect for it. And so I was kind of curious they hadn't announced anything. But like even once again, using something like that, where it's a pretty well-known standard and could be used for other things. I mean, they're talking about putting them on the top of parking garages. So I don't know how many semi trucks are going to go to the top of a parking garage. But and that's where I was kind of thinking, I was like, well, yeah, if you did like the NACS thing, then while if you're not charging a eVTOL, you could be charging someone's car and charging money for that. But that's a
Yeah.
whole nother thing, and I'm not in that business. So
Yeah,
with
the
that,
Tesla
that's
folks seem to think that they can get close to a megawatt out of the NACS connector, which if they can do it, power to them. Maybe that's a cheaper way to do it. Getting power to the site is another question entirely. Getting utilities to provide that power can be a challenge.
right. I think I kind of agree with you. I think it's really cool that they designed it and they kind of pushed it to be that. I don't know how practical, but like you were saying earlier, CCS1 and CCS2 were kind of maxed out as it was.
Yeah.
And from a future proofing standpoint, and if your plans to only use it mostly for regular vehicles, then yeah, that gives you so much headroom and then some that it does seem to be pretty well future proofed. If you wanted to go up to semis, I don't know. But you could at least even as like a backup have it that like, even if you can get to like we're talking about 700 kilowatts, it's kind of a nice backup thing to have if you're building a site anyway.
Yep.
But no, I'm curious, have you had many discussions with the traditional like fueling stations around like the pilots, the Flying J's, or kind of the commercial Pacifics that are traditional fueling stops for truckers around moving to kind of an electric future, and what feedback they have? Because the reason I bring this up is one of the things we've talked about a lot on this podcast is, especially around CCS2, is the challenges, at least domestically, around Electrify America, not to finger point, but as an example, that have struggled with charging infrastructure. And now you're starting to see some of it through federal funding, others just kind of through general interest. You're starting to see the Flying J's, the pilots, enter that space. And for them, there's never really been a strong business model in fueling. It's the stuff they sell when people stop to fuel.
It's what they call cokes and smokes. That's how they make their money.
Exactly.
I will say that the conversations with the Travel Americas and the Loves and the Flying J folks were really, really frustrating back in
interesting
the late teens and the early 20s. There was a real lack of any interest or desire to get into the charging space by any of them. I'd say that's substantially changed now. Every single one of the major fuel refueling rest stop / Buc-ee's, what have you.
Yeah.
They've all got some sort of a charging partner, and they've all got some sort of strategy that they're going into. Some are well thought out, some are less so. Not all of them have consideration for larger vehicles than light duty. Some do, some don't. So, the proof will be in the pudding. Everybody's in the early stages of it. But it's an area of industry that's ripe for disruption, which is why I consult and I'm on the advisory board for Watt EV. So when we built Electric Island, there was this couple of guys from down in the LA area that kind of kept calling me up and asking me questions. And I've always been one that's like, one company can't do it all. We need as many people in this space to be successful as possible. If you're an honest broker, you are honest with the market and honest with what your technical capabilities are, and you're in it for the right reasons, I think you should succeed. So there's a couple of companies that maybe fall outside of that exclusion zone. I won't name them, but if you're honest and upright, forthright with the market, let's see you succeed. So Watt EV came about as an idea from these guys that they wanted to provide essentially identical versions of Electric Island scaled up for the market. And so power to Portland General Electric and a couple of my predecessors in the utility industry up and down the West Coast, there had been some pre-work done to establish what a West Coast clean transit corridor would look like. I did some more work on that when I was at Portland General Electric. It's a partnership between all the different utilities up and down the West Coast. And it was a pre-plan as to what needs to be done in order to allow freight to move from San Diego to Vancouver, BC. And so the sites have been reviewed, the desk reviews have been done, the upgrades have been identified, and essentially all the utilities are waiting for is a customer to come in and say, I plan on asking you for 12 megawatts at the site in the next, or 2 megawatts or whatever it is, let's get it done. And they can pull the desk review out that they've recently done and move forward with that. And Watt EV and others have started to do that. So it's really exciting to see them move into a business that's never been a business before. It's truly unique. It's new. No one's ever built for-profit public truck charging and bus charging sites before. They saw a unique opportunity in that if you have a public charging site, you're only making money if you're dispensing energy. So if you've got only a small volume of trucks out there, you're not going to have a lot of customers. But there's also within the Los Angeles area for the ports of Long Beach and LA, most of the drayage carriers, the folks that go and pick up containers, are small fleets. They're mom and pops. They run from 2 to 5 trucks. And the way to get them into an electric truck is to lower the barriers to entry. And so their Watt EV has actually purchased a number of electric trucks and offers them as truck as a service and charging as a service to these customers. So they can simply pay a monthly fee, charge up at the Watt EV sites, and then go pull freight zero emissions at a port of LA and Long Beach. So it's kind of exciting, and it's neat to see them succeed. They've got one site up and running, and they'll have 3 more open, I think, by the end of this year. One in Bakersfield, one in Inland Empire, and it's really exciting to see them grow.
Yeah, it's interesting you mentioned ports because I've had an interesting conversation recently with a company that's focused in the commercial charging space, but they're approaching, and there's a couple doing this, but they're approaching it with wireless charging. And I was kind of curious with MCS, are there any protocols or any standards for, or kind of like future proofing built to do it MCS level charging wirelessly? Or is that kind of still a little bit of a Wild West and a separate thing? I know you also had mentioned doing just having robotic charging to kind of automate the process anyway.
So I think that chapter has not been completely written for charging yet. You made a mention of truckers and being on the road for a certain length of time. As we reach automation for driving, and I don't know what kind of electric car you have, but I had a Model Y and I had a Model 3 in the US. And I drove through Wyoming without touching the steering wheel. And I literally took, I think, 97 pennies and stuffed them into a rubber racquetball and hung it from over with the string over my steering wheel, so it had enough pull on the steering wheel. And on the freeway, that car drove with 100% degree of certainty. And so it's entirely within the capability of autonomous driving on freeways for trucks, I think, to operate on freeways autonomously. And so if you extrapolate that further, if you have autonomous trucks, they need to be electric so that there's zero emission. And if you have electric autonomous trucks, then you have to have some way to autonomously charge them. Whether that's a robotic arm, whether that's induction, I don't have an answer to that. I don't think anybody knows what that answer is yet. Induction does have some challenges as far as the orientation, making sure that they're the coils are directly oriented. There's no misdirection because you get a lot of heat and you get a lot of power loss between the two. The coils being carried on the vehicle can be quite heavy if you're going to convey that much power, whether or not that's efficient because you have some energy loss there. Those things need to be solved. Again, I don't know. MCS was kind of the next step as far as what we could do from a conductive point of view, whether it's a robotic arm that goes and sticks that in, or whether we have some sort of inductive solution. I don't know. But if you talk about autonomous vehicles not having a driver, or maybe having a driver at the wheel that's simply monitoring, then why would you have somebody that has to go shove the thing into the vehicle? There's got to be some sort of autonomous vehicle.
Yeah, it's the reason I asked that, it was kind of interesting how these conversations, and I kind of go back and forth on the value of the technology because they were approaching it using radio waves, so you kind of get around some of those issues that you were talking about from the hardware standpoint, and you still get pretty high efficiency. But a big part of it was just the fact that way they don't even have to train or deal with the people plugging it in on their brake. And they were talking about, for a lot of these were transit electric vehicles, like the person could just pull up, have people get on and off, do a quick charge without even knowing it. Or when they take their break for lunch or whatever, if they just park it somewhere, they don't even have to think about actually plugging it in. And so from that standpoint, there's some really interesting things. And the fact that there's really no moving parts versus kind of the robotic thing is also kind of a long-term value proposition to it. But right, I kind of agree with you. It's like, it's interesting, but it's still kind of early days to see which one's going to really make it out in the long term.
Yeah.
But
And there's some
it's
folks
interesting
working on
you
it,
mention it.
For municipal bus and that sort of thing, you've got pantograph. Those go up to really nice high powers. You install those pantos at certain brake sites or places that a bus is going to be for long, 5 minutes or less, or more. Sorry, and yeah, panto is a great solution as well.
Yeah, and I think what we've been talking about today is semis, and there's probably a use case, especially if it's a short trip one. But it seems like a lot of these are more focused on either transit or maybe even ports were a big one for them too.
Yeah.
And so, but we talk about autonomy, and I'm kind of curious what you have seen and what you've experienced. I've actually had a lot of professional and personal experience around autonomy, but obviously kind of the light duty side of stuff. And from what you were even talking about, you're totally right that I mean, I actually have a Model Y too. I've driven through Wyoming quite a few times, and you're exactly right. You just kind of hit the thing, and it's just straight.
You're just sitting there watching the road go by. You don't have to do anything.
Yeah. And so, I mean, the only thing you really have to worry about, I've done it a couple times, and you can get a pretty big headwind. So you just have to figure out where your charging stop is.
That's correct.
But
That's
I mean, other than that's, and as if you're, once again, if you got the Tesla thing going for you, it's still a pretty straightforward process. But that is one of the few times I actually got close to getting into trouble, was the headwind was just hitting my range so much. But that's a whole different story. So with autonomy, what have you seen around that, and what whether it's your own experience with it or just kind of your kind of industry knowledge that you kind of see the future of that, or how realistic and how soon is that for an option for semis?
So the Venn diagram of autonomy and electric, you would think, are kind of the same circle, but they're not. So autonomy works really well in commercial trucks, for the longer hauls, and the long haul and battery electric trucks aren't a great mix just yet. It's great for driver safety on highway and freeway, but again, battery electric trucks don't get you on a long haul. So autonomy is definitely there, as we see. With Tesla, there's the what's the Ford, the something blue. Chevy's got theirs. I mean, there's the Mercedes has theirs. Everybody's got some sort of a version of autonomy out there. On commercial vehicles, from a safety standpoint, I would much rather have a driver with an autonomous software feature available to them to keep them safe. I mean, I want them to have that because it doesn't get distracted. It's constantly vigilant, and it's not like a human. It's not going to get sleepy. It's not going to potentially be impaired by drugs or alcohol. And we know it does a solid job in certain operating parameters. On freeways, it's bulletproof. When you get into non-freeway situations, that's when it starts to get a little wonky. I don't think we're there yet, and I don't think that we're there yet for a while. But there's a lot of folks working really hard on trying to get it dialed in. I think they'll get there eventually. But I mean, I was reading something about an autonomous vehicle, one of the Waymos, I think, and they came around a corner one time, and there was a woman chasing a flock of ducks with a broom. And it's like, how do you program that into your Waymo as, what you do when you encounter a flock of ducks being chased by a woman with a broom? So it's just, as a human, you're just like, you just go around. But how do you program that into a computer?
Yeah, and it's funny you mentioned that, because one of the things that Tesla had mentioned when they first announced the Semi, it's an interesting idea, but they haven't really talked about much, was the concept that you could actually have like 3 electric trucks, but 1 driver, essentially, where they would be, the first 2 would be kind of falling. And that, in theory, kind of makes sense. And you kind of get maybe the best of both worlds, but it still seems like that's a ways off. And there is, especially with long haul, at least talking to people, there still seems to be, whether even when you take charging outside of it, there's kind of the loading and unloading, and there's still an element of human labor required with that. So it kind of makes sense to have a driver.
Yeah.
And obviously in those kind of more dangerous situations. But yeah, if you can get autonomy for that and charging to that point, then it does kind of make sense that maybe you can get to like 3 trucks and 1 driver, which is an interesting idea. It still seems like a ways out, but do you see that as being a realistic possibility? Or
I don't know how much exactly I can say on that one, because some of the conversations I've had about that issue were internal when I was working on the topic at one of my previous employers and with others inside the industry. I will say that by and large, the challenge is latency,
yeah,
which means the time it takes from the signal to travel from one to the other, and whether it's going through a tower or a satellite. And so if you talk about freeway speeds, 70 miles per hour, and if you have a latency of half a second, how far will that vehicle travel in that half a second? And if the signal
right.
is just that much late, potentially you have the vehicle doing things you don't want it to do. So it's a difficult one to overcome, because physics says that a signal can only travel
Yeah,
so fast through the Earth's atmosphere. So
for sure. And while it's controversial, I think that is always one of the areas that Tesla and Waymo actually have been really good about, is having so much of the thinking, whether it's them or someone else or a Chinese company that comes up with it. I don't know. But like, I do think that core concept of having so much of the actual thinking and processing being done in the car versus being sent somewhere else and then,
yeah,
or being remotely done, just inherently removes a lot of that challenge. I think that's a great fallback, or some safety elements to it. But I mean, we see so many times that cell towers or other things happen where they go down, and
yeah.
at the end of the day, that car is moving down the road and has to make the decision.
Exactly. It's got to be able to
So
say,
that,
there's something stopped in front of me. I need to stop. And
yeah,
that vehicle needs to make that decision without having to go back to the central computer and say, should I stop?
right. Or is this, yeah, what is this thing I'm seeing shooing a bunch of ducks across the road? Should I just
Yeah,
keep
exactly.
driving? Do I, yeah, I
Yeah.
mean, that's exactly that kind of stuff. So no, I understand. I appreciate you saying what you can about it. We've talked a lot about the charging infrastructure and kind of the design and the sports of it. So let's talk a little bit about the actual trucks and your experience with kind of designing and working with companies building those. Because
Hmm.
as I was said, I've been talking to my friend who works in the industry. He definitely is focused more on the long haul stuff, and we are seeing, obviously, for fleets, it's, and large companies especially have those. I think more clear business cases, and then a lot of large companies even have certain requirements that they're making around sustainability and other promises that are kind of accelerating and kind of pushing them to go towards that anyway. But some of the things I've heard that are kind of against, especially if you're a smaller operator for a truck, is one of the big things is actually around the weight and what can an electric truck actually move. I know that traditionally semis have had like an 80,000 pound requirement, and that's kind of changed a little bit with here in the US. I think they increased it to 82,000 pounds if
Yeah.
it's electric or something.
Yeah.
But
If
I'm
it's
just
got
curious
some
if,
sort of a ZEV or reduced emissions drivetrain, I believe natural gas falls into that as well. So if you've got, and the hydrogen, so they get a two-ton dispensation.
which is something, but especially once you're talking around a megawatt hour of batteries, it could only be maybe a fifth of that. So,
Yeah.
but I mean, obviously, diesel engines are super heavy. Carrying all that fuel has its, they're it's not a completely one or the other. It's, I think, closer than most people realize. But I am kind of just curious if there's any of that you can kind of talk about or share around the practical applications and how much of a difference weight actually plays into the effectiveness of electric semi trucks.
So weight is definitely an issue. You know, the initial battery electric trucks were heavier. I believe the Tesla semi is still heavier than a traditional diesel ICE. But I think we're getting there. Like I said, the gravimetric and volumetric density of batteries continues to come down, as well as price. So you have all of
Yeah.
these slopes from technology and price that are headed the right direction. So we'll get to the point where they're lighter, and have just as much power on board, if not more. And we already see cases where it's cheaper by far to operate electric trucks. If you have runs that are 100 miles or less, or 150 miles or less, and you're running an electric truck versus a diesel, it's cheaper. So the question I'll ask you to ask your friend who's involved in the long haul is that when the industry moved from horses and trailers to gasoline trucks, did they still take the gasoline trucks to the barn to feed them hay and rub them down? The answer is no. They changed the way they operated, right? And so when you're changing from a diesel truck to a battery electric truck, you have to change the way you operate slightly, not totally, but you have to take into account your percentage of charge when the truck returns, the scheduling of drivers to complete certain routes, and how far they're going to go with that route on that particular day, and what the charge rate of the truck is, and how much power it's got on board. You have to know these things. We have the ability to track all this information. You have the ability of a dispatcher to choose from 4 trucks and say, okay, this one needs to go 200 miles, and I've only got one of the trucks that's capable of doing that right now because that one's at 95% steady charge. So go take that one. We'll put this other truck on this route. Those things are doable and are capable of being done under today's today's technology.
As we wrap up the first part of our conversation, we want to extend our deepest thanks to Rustam Kocher for joining us and sharing his profound insights into the electrification of the trucking industry, the challenges and triumphs of implementing the Megawatt Charging Standard, along with the past, present, and future of electric trucking in transportation. Rustam's experience and visionary work truly illuminate the path forward for sustainable transport. I'm really excited to share part 2 next week with you as well. I can't thank Rustam enough for his time and what we covered. Remember, if today's conversation sparked your interest or curiosity, we encourage you to share the episode with a friend or colleague who would appreciate these forward-thinking discussions. Spreading the word helps us grow and continue bringing you the cutting-edge content you love. Plus, don't forget to sign up for our weekly newsletter to keep up with the latest trends, expert interviews, and behind-the-scenes content from Grid Connections. Your next dose of inspiration is just an email away. We also want to hear from you. If there's a topic you're itching to learn more about or a guest you'd love to hear on the show, drop us a line. Your feedback shapes our show and helps us cover the stories that matter most to you. Remember, just email us, guests@connectingthegrid.com, or reach out to us on our social channels. For those of you who are intrigued by Rustam's work and want to dive deeper, remember to check out the show notes for more information and links to his current projects. There's always more to explore after the show. We're grateful for your enthusiasm for the subjects we cover on this podcast. Thank you for tuning in, and until part 2 next week, this is the Grid Connections podcast signing off.